Okay, let's get started. So thank you all for coming today to this series of workshops. Um, so let's see if we can go forward. All right, so this series of lecture sessions is going to be talking about how to design systems in the context of the web. So I think probably the most important thing that you do in anything that you're working on, in particular in software engineering, is figuring out what the software you're going to build is going to look like from an architectural point of view. And if you do this correctly, you might save hours or weeks of actually writing code. And if you don't do it correctly, well, then things can go sort of unpleasantly very quickly. And I think getting this kind of skill for me has been very difficult. But I've realized that it's something that I have to get better at if I want to move forward in this space. And so you can approach this kind of thing of like, okay, well, how do I design a system in a number of different ways? But I think one way that is probably accessible to most of us, at this point in our in our experience of software engineering is like through web systems, right? Because most of us have some experience with building websites for something else related to applications on the web. So the goals of the next 5 sessions will be to kind of understand what the big picture looks like in the space of designing applications for the web, understanding where we have to make trade-offs between what we do. So for example, sometimes you need to sacrifice performance for higher security in your applications, or you have to sacrifice performance for usability, or you have to sacrifice usability for performance, and these kinds of things. So getting an idea for what are the kinds of things we need to think about and what are the trade-offs between those things is a very important end goal we want to reach here. What's not going to be a goal is to learn any specific technology. So there's a class here at Vanderbilt that talks about how to build web applications, and I haven't taken it, but I've heard very good things. So I'm not going to try to regurgitate any information from that. I think there's plenty of resources for that online as well. I think what's a little bit more useful is to have a discussion about like how do we actually build something sustainable, right? Okay, so here's like kind of like a quick visualization of what I'm trying to talk about. So if you kind of think about like from a math perspective, you have this like space, this 3D space of all possible applications you can build, right? Some are going to be really, really bad. They're going to be these, these curves that go towards the bottom of the z-axis, and some are going to be good. They go towards the top of the z-axis. And like maybe there's this like big global maximum at the very top, but there's certainly a lot of local maximums too. And the question is, well, maybe we can't get to the global one, but at least maybe we can try to get to the local maximum and have a web application that's like good enough compared to what else we could have had around that area. So how do we sort of figure out how to get up to the best application we can have? And obviously this is a rough analogy, but I hope this kind of idea of what we're going to talk about makes sense. So, we're going to do this over 5 sessions. Today, today in the next session, we're going to kind of sort of warm up to this idea and talk about sort of review and talk about what the infrastructure for the web even looks like. So today we're going to talk about how how you build a front end for a web app, or what your UI looks like, and how the browser actually renders that kind of stuff. Next time we're going to talk about stuff like networks and how do you send data like between web applications, that kind of thing. And then from there we're going to talk about, okay, well, now like we want to start building serious applications on this infrastructure. How do we actually do this, and how do we do it in a way that it doesn't fall apart and try to add like some new component? So we'll spend 2 sessions on that, and then the final session we'll kind of look at some things that we weren't able to look at in the previous 4 sessions, and talk about what are kind of like the next things you can do going forward to better enrich your own knowledge of what's going on here. And so like this is a very important point that I want to make here is I think a very important question for you to ask as a listener to me is, should I believe what Ayaz is saying? And the answer is like, maybe you should, but like take it with a grain of salt too, right? Because at the end of the day, I'm also like just a student. I'm probably like, your age or 1 year or 2 years older than you. And I have some experience in this area, but like I'm by no means an expert, right? And the other very important thing here is that what we're going to talk about are very, they're sort of opinionated things, right? Because if you say, well, here's one thing that I can do, and here's the second thing I can do, and I think this one is better than the other thing. At the end of the day, this is kind of like a value judgment, right? It's very difficult to say that one thing is like definitely better than the other thing. And it's very easy for me to kind of say my opinions about what I think is good and bad, but I think what's a lot more valuable is, for all of us to have a discussion. And maybe I start off and I say, okay, well, here's what I think. But if someone else jumps in and they're like, well, you didn't think about this point, and actually, here you said something that I just don't believe because I have some more evidence than you do. And when we have those kinds of discussions and we start engaging in dialogue about where our beliefs start to differ, I think that's really the most valuable stuff. So I really want to encourage you, if you're listening to this and you're interested in this, like please ask questions and make comments at anything that I say, because I definitely don't want to be here and say that I know everything or even close to everything. I just want to be here to kind of present my viewpoint on what I believe, and hopefully, you get something out of that. But I think it would be enjoyable for all of us if we kind of talk about this as a group rather than me just presenting, some beliefs that I've accumulated over the last few years. So I hope that all makes sense. If I've been going too fast, let me know. But this is kind of just like logistical stuff that I wanted to get out of the way and present what we're going to talk about moving forward before we really get started on today's session. So yeah, again, if you have any questions or comments at any time, feel free to jump in. I would appreciate that a lot because, yeah, all right. Go forward. All right, so I guess logistics-wise, it's not a lot. I'm sure all of you that are attending this have an email about what the schedule for all this stuff looks like. So I've shared the slides that we're going over right now in the chat. I'll find some other way to broadcast them out to all of you after this is over. If you ever want to email me, here's my email. Again, feel free to contact me at any time. I usually reply pretty quickly because I don't have anything better to do because it's COVID. And I have a chat message. Yeah, thank you for putting the link to the central repository. I actually don't think there's anything there right now, but I'll update it after this meeting. And yeah, so we'll meet 5 times. Today's the first time, and then the other 4 times will be 6 to 7 p.m. every other Tuesday. We might go a little bit over today, but I'll try to keep it down. We'll see. We have a couple demos, but we might skip them, or at least one of them. All right. Okay, so let's get on to what you're probably really here for. Let's start talking about what's going on with web applications, right? So, like I said, today we're going to talk about kind of an narrow view here. We're going to talk about, all right, you have some web application. Obviously, your web application has to have a UI, a front end that people can access. You make it really pretty. It looks great and all of that. But what is really going on in terms of how does like the browser render your UI, and what are kind of some of the consequences of how your browser renders the UI that may not be immediately obvious. Because I think it's very easy, to write some HTML and CSS and say, okay, I'm done. But as we will see, browsers are kind of a leaky abstraction, and it's not just like you write some HTML and CSS and you're done. It's like, well, if you write them in one way, your browser is going to optimize it, and your UI is going to be very fast. If you write another way, it's going to take ages to actually, draw all the pixels to show what you want your UI to look like. And same thing for JavaScript. Like you can write some JavaScript that's very fast and optimized. Write some JavaScript that takes ages to run, and then you get into this whole problem about like, well, okay, what's the difference between how Chrome works and this horror story of how Internet Explorer works. So there's a lot of things that are going on that are a little bit deeper than just, okay, like I just need to write some code and I have whatever I want. Okay, we'll get to that a little bit towards the end. Before we get there, I want to sort of review how it is that you design, how it is that you design a front end for web application and what are the languages that are involved in there, just so that we have kind of like a ground to start working on. So I'm going to assume that everyone here has a little bit of experience with building a website and they know what HTML and CSS and JavaScript are. But I'm not going to try to assume more than that, and we'll kind of build on it gradually. Okay, so let's say you want to build a UI. What are like the three components that you need, or like three kinds of files that you would write? And this is an interactive question. I would love an answer.
Definitely HTML, obviously for content, and then CSS definitely for styling. And then probably if you want to add some extra functionality, then JS.
Yeah, exactly. So Kev got that straight on. Like, let's just say when you build a web app, you just have HTML, CSS, and JavaScript. And there's like all this other stuff that you can say, like, well, you can add this additional stuff, but let's kind of forget that for now. Let's just say, all right, this is how we want to build some front end. Right? Okay, so what is HTML? So HTML, like you write an HTML file, and what is it? It's just some text, and it's kind of in this like hierarchical shape that describes like what your page is supposed to look like, right? So like here we're going through and we're saying, all right, here's like my head. This is basically just contains some metadata for the HTML page. So here I'm just saying the title of my web page is hi. My browser is smart enough to be like, oh, okay, he wants the title of this to be hi. I'm going to put this hi right here. And then in the body, you say, you again do this hierarchy and you say, all right, like here's how the content in my page is going to be laid out. So I have this div, which basically puts like a block on the web page, and inside the div I have some text, hello, and then I have like the span thing, which just puts like a container around some other content. And the other content that I have here is just world, right? So kind of an intuitive model, right? You're basically just saying, all right, this is how I want you to lay it out. Because it's hierarchical, it's very easy to understand what's going on. You see like what all the nestings should look like. Obviously, we don't have a very, very complicated example here, but I hope this makes sense to everyone. And of course, if it doesn't, feel free to say something or put something in the chat, and we can talk about it more. Okay, so then you're like, well, this thing is not that pretty. I want some colors, and I want to do some other stuff. So you're like, all right, well, now I need to write some CSS. And again, CSS, like you open up a file or you inline it into your HTML and you write some text, and you basically say, all right, like here are the things in my HTML, and here's the styles that I want you to associate with it, right? So previously we had this div. Let's say I want to make everything inside of this div green. I would create this style, some style for div, and I would say, all right, my color is this medium sea green thing. And then let's say, I want this world to be italicized and bolded. So remember, our world was in the span, so let's just give every span, let's just make all the content in it bold and italic, right? And the important thing here is that we're associating our styles directly to the HTML, right? It's not like we're saying, okay, I want you to kind of just like guess and figure out where this should go. We're explicitly saying, whenever you see a div, apply the style. Whenever you see a span, apply the style, right? Okay, so now we do this, and our web page looks nice and pretty, but it turns out we want to say hello to a few more things than just the world, and so now you need some manipulation of the web page. You need some interaction, and so for this you can add some JavaScript, right? So again, you open up another file, or again you inline it into your HTML, and you add some text that tells the browser, what it should do to the web page in terms of data manipulation and affecting the user experience on the web page, right? So this gives you something a little bit more dynamic than what we can just represent with the static contents of an HTML file and the static styles of a CSS file, right? So here we have a very simple example of just some JavaScript that loops through like 4 different words that I have here every second, and every second it just changes the text inside of the span that we had before, right? So I hope this also makes sense to everybody, and even if it doesn't, don't worry, because we're not going to look at JavaScript again this time. But if this is confusing again.
Can you potentially talk more about what a DOM is?
Yeah, sure. So there's like this really complicated way to explain it, but I think probably the only thing that matters for us right now is like the DOM is sort of the concrete model that the browser builds up from the HTML, right? So with our HTML, like we had some text, right? And we said, here's how our web page is laid out. When the browser goes to actually render the web page, like it can't just look at this. Like, I guess what I'm trying to say is the text itself is not the pixels that you're seeing on the screen, right? The browser builds out a model of how the web page should look like, and that thing becomes the DOM. So you can say that your HTML and your DOM are analogous, and they basically represent each other. The difference is just that the DOM is like a concrete thing inside of the browser, and the HTML is the text that you've written. Chat. That sound, so the comment was, that sounds kind of like a compilation. Is that wrong? No, that's not wrong at all. And that's what we're going to get to now. So yeah, I guess just to wrap up, like the point of this JavaScript stuff is so that you can write some code that manipulates the state of what the web page looks like inside the browser, which is this DOM thing, and it provides you like a channel to talk to it. And so now we get to Kev's point. Oh, this is a comment I had. Maybe we'll get back to this one later. But here's what I really want to get to. So, like Kev was saying, if we think about what's going on here, all the stuff that we've written is just text. Like on their own, they don't really mean much at all. Maybe they mean something to us as humans because we see it and we say, oh, okay, like that looks like HTML, or that looks like CSS, or that looks like JavaScript, right? And we can get some idea of like what the intention of their contents is, But if we just give them to a machine, like what is a machine supposed to do with just a bunch of text files? Nothing really, unless you tell it some way to to actually process that data and interpret that data in a certain way. And this is exactly what's happening, right? So when you open up an HTML file in your browser, it's not just your browser is like, oh, okay, like magically I'm gonna know what I want your thing to look like. It has to go through a process of you know, for lack of a better word, like literally compiling down the HTML to a set of instructions that tell it how it should, you know, render pixels on a screen, right? So this is like a nice graphic from the Mozilla Hacks blog that kind of gives like 1,000-foot overview of what's going on. So you give it some HTML, it does this thing called parsing where it says, okay, like here you have a head thing, you have a head tag. What's inside of your head tag? Oh, you have a title. Okay, so now you're done with your head tag. I know what's inside, what should be inside the head. Then I look into the body. Okay, I see a body tag. What's inside of the body? You know, I have some text and some other nodes or whatever. And it basically builds out this thing called a parse tree that roughly describes, you know, what the page should look like. Then, you know, it does a similar kind of thing for the CSS file. It figures out what all the styles in the web page should be. It links them up with what it figured out the HTML should look like, right? And then it goes through this process of effectively compiling everything down into a set of instructions that tell the browser, okay, here's how you should lay out, you know, the stuff, you know, the different parts of the web page, and how you should actually display each individual pixel on the web page, right? Yeah, so, you know, we just went back, we just talked about this in a little bit more detail, but this is the point, that HTML and CSS are just instructions to the browser for how it should render a UI. And the browser has each browser has a very dedicated component called a rendering engine that is responsible exactly for this job, right? And so here's like some code for like how you might do this very rudimentarily, right? So let's say this is for like rendering a div or something. So, you know, you have a div, which is a block with some text in it, and you can also have like a background color. So how do we generate the, you know, the box associated with the div that has some background behind it? Well, let's say the div is stored inside of this variable that we have called a box. Then we say, okay, we'll figure out the color of this box. Then, you know, let's just say we want to just generate some commands to draw the top border of the box. You know, then you figure out the dimensions of the box, you figure out what the color of the border should be, and you create a command for this thing called the rendering engine, and you say, okay, well, here's where I want you to place this thing that should look like a border. Here's its color, here's its dimensions, et cetera, right? So like you know, if you then think about like how much complexity is there to this, there's quite a lot, because if you think about like how many different kinds of HTML elements there are and how many different kinds of styles you can apply to each individual HTML element, and, you know, those combinations of styles, intuitively it would kind of seem like the browser has to do a lot of work to do this all correctly and in a consistent manner, right? Because one other dangerous thing that might happen is, you know, if you have two browsers like Chrome and Firefox, for example, and you have some web page, and you load the web page on both of them, but they render it differently, well, like what are you going to do now? So you need both of these browsers to have some kind of consistency in how they're going to display web pages, right? And so there's these folks that write really long standards for both HTML and CSS. So here, I tried to print out what the HTML standard was. Of course, I didn't do it because it's 880 pages. But the point here is just to give you some sense of the fact that this is not like a trivial operation at all. People spend lots of money, or I should say companies spend lots of money to get this kind of thing right. People spend many years of their lives just writing web browsers as projects because it's certainly not a trivial task. Okay, so here's like one thing that we haven't talked about so far, but now that we have some idea of what the browser is doing when you give it some HTML and CSS, let's say you have like some CSS file that you kind of just wrote like willy-nilly, and it has, you know, a bunch of styles that are kind of confounding or sort of overlapping each other, or they're structured in such a way that you have to repeat yourself many times. So can you think of any consequences that this would have with regard to how much work the browser has to do?
The browser might have to go back to a specific element and change the styling of it every time it sees like another style. So finding that specific element might take a lot of time.
Yeah, exactly. So even linearly, right? So like if I have, you know, if I have some CSS with one style versus two styles, obviously the two style one is going to take longer to render because the browser has to do this work of figuring out, okay, well, you know, what is the extra work that I need to do to actually display the style? So even as you linearly increase the number of styles, the work that the browser has to do increases, which makes the time it takes to render your web page slower. And of course, as Ilya is saying, if you also start like confounding your styles and there's like lots of overrides between them, then the browser is doing even more work, right? Because at each point you have some kind of overlap or some override. It has to go back and say, okay, never mind, get rid of that thing. Let's put this one here instead. And so I'm sure that you can make some analogy to what this would look like in your own life, but I think of it kind of like, you know, if you went to the grocery store and you know, instead of like putting things in bags, you decide to kind of take things one at a time. It's like, what are you doing? You have to run back and forth constantly, and you're sort of wasting a lot of things that you could have done. Wasting a lot of energy that you could have saved if you sort of thought a little bit about how do I like make the operations that I'm doing a little bit more efficient. And the reason that I mention this is because it's not a trivial thing to notice, right? It's not like you give your browser a CSS file and it says, oh, wait, this one is very complicated. It's going to take me some time to render. And it says you should improve it. This is a thing you kind of have to figure out for yourself. And you know, nowadays there are some tools that you can use, and it'll tell you if your website is slow or fast. And it'll tell you, okay, it took me this long to render your CSS. Maybe you can do better. But if you're just starting out and you're writing a website, I think it's not very trivial at all to realize, oh, if I don't structure my styles or my HTML in a certain way, the consequences for how the browser is going to render them are going to be very different. So this is just pointing out something that you might want to think about. Yeah, so as Ilya was saying, the browser has to do more work to render just the web page itself. And the other thing that we didn't mention, but as you might imagine, like if you have a lot of styles and you have like a lot of different things going on, it's harder to manage as a developer, especially if you're working on a team, right? Because then you have to do like a lot of mental juggling to figure out, okay, well, you know, like I had this style here and then it got changed to this thing and then got changed to this thing. Like, it's hard to get a sort of visualization for what is going on in the code and translate that to what it would look like on a web page. And so you have to start doing a little bit more work there. Let's skip that. Okay, so this is another question, but we'll get to this one a little bit later. I'm gonna skip it because we're about halfway through. I want to get to JavaScript. But okay, like this is an interesting one. I'm curious to get any of your thoughts. So again, let's go back to the like Chrome versus Firefox example. And it's like you also have like Internet Explorer. Let's say each of them displays something a little bit differently. So maybe you know, choose your favorite CSS style and say that their behavior between all three browsers is different. What are the consequences for you because of this?
I think one of the biggest examples is like animations CSS with different browsers, right? Because you have to fit them for Mozilla, Chrome, and then other stuff. So I think you either have to write more redundant code or would not expect, like, did not realize like it works on Chrome, so it might work on everything, but like people realize that different browser engines might display different outcomes. So like the developer might not also know the results.
Yeah, exactly. So as you were just saying, like, first of all, now it's you having to do more work, right? Because now it's not enough to just open up, whatever you have on your desktop. You need to open up every other possible browser that might be used by your users, because you don't know what the behavior is. Sort of trivial. You have to go and test it out. And in fact, like there's this whole sub-industry in the software space now where there are these companies that have made a business for themselves, like just providing ways for you to test your websites across different browsers, right? And this is kind of like a crazy thing to think about. If this had been kind of done in a different manner, perhaps there wouldn't be this need for like these multi-million-dollar, sometimes even like $500 million valuation companies to be around. And so on the one hand, you're like, okay, well, that's great for them, they're making a living. But on the other hand, you're like, wow, at least to me, it's kind of shocking that you kind of get to this point where there's just so much diversity, and you're sort of inundated with the fact that you have to do a lot of extra work just to get to the point where you can say, okay, I'm confident that this thing works. Because it's not that way when you write, code in C++, for example, right? Maybe you have to like compile it with a couple different compilers, but if it compiles with those compilers, you're reasonably certain that your code works. Most of the time, you don't need to go out and try it on a different machine and see if it works there too, because you trust the compiler to do that correctly for you. But here, it's a very different thing. Yeah. So exactly. So as was mentioned, we have to spend a little bit more time trying to figure out what the behavior between different browsers is and how to make sure that it's consistent in our web applications, either by adding more styles or having to do more manual testing. Okay, so now let's turn to JavaScript. And so here, we're going to say basically the same thing that we said before about HTML and CSS, right? So on its own, if you have some JavaScript file and you feed that JavaScript file to the browser, like through your web page or whatever, again, if you don't tell the machine how to interpret it, it doesn't know how to do anything, right? Because it's just like some series of bytes. And it's like, well, like, tell me how I should look at this. Because it's not as intelligent as we are, at least on a very macro level. You have to give it a lot of information for it to work on it somehow. And so again, just like each browser has a rendering engine, every browser has a JavaScript engine that does kind of the same thing that we talked about in terms of how the rendering engine processes HTML and CSS. So it takes in a JavaScript file, parses it, which means it just puts it into an internal representation where the computer can understand. And by understand, I really, let's put that with very large quotes around it. What the code is saying. It analyzes code and says, oh, okay, like here are the machine instructions that I should do. And then it starts, evaluating those instructions in your web page. So for example, if you have a counter and you say, your counter is called I, and you say ++I, the JavaScript engine will put that into some internal representation. They'll say, oh, okay, like this means, go to this place in memory, update it, update that place in memory by this amount and put that back in the same spot that it was in memory. Yes, so nowadays, a lot of these browsers also do this optimization part where they actually compile the code that you write into machine code and then execute the machine code, which is a little bit faster than just interpreting it directly. But if this doesn't make sense to you, it doesn't really matter. The point here is just that the JavaScript engine looks at your text, figures out some way that it can understand that, again, in big quotation marks, and starts and says, okay, now I know what to do. I know what I should, I know how I should modify my internal memory to do the things that you have specified for me to do in your JavaScript file. So again, I realize there's a lot of hand waving, but the big point that I want to make here is that there's work going on for your browser to actually be able to run and evaluate your JavaScript. It's not just like you load the file and that immediately, like the JavaScript itself is not code that the machine can run. It has to take some steps to figure out how it should interpret that. So now, like if we start thinking about what this means for the browser to evaluate JavaScript for a web page, one thing that becomes clear kind of immediately is that every web page that you have open on a browser has to run the JavaScript associated with it separately, right? Because imagine if you had two web pages like running JavaScript, sort of in the same context. This would open up a lot of opportunity for failure, right? For example, unless you're really careful, one immediate thing is like, well, what if you have the same variable name between the JavaScript, on New York Times and the JavaScript, what's like another website on Reddit or something, right? If there's a common variable name and you try to run these things together, like it's going to fail really quickly, right? So obviously that model is kind of out of the picture. And it becomes clear that every tab has to run the JavaScript associated with it independently. This is an important fact because if you think about this a little bit deeper, you're like, well, that's kind of crazy because if I have like 50 tabs open, what does that mean? That means there's like 50 different JavaScript instances running, right? So think about it as if like, you had some C++ program and you were running it 50 times. Well, if the C++ program is, is very small, maybe it's not a big deal, but imagine you're running a sophisticated application and you have 50 of these kinds of instances, right? It can start to sort of weigh down what your machine can do very, very quickly. And so you can imagine if you have 20 or 50 browser tabs open, what does that do for the browser that you're running? We might imagine that it slows down tremendously, right? Okay, well, I just answered this one, so that's my bad. But yeah, so as I was saying, if a lot of things are running at once, we might start to see some slowdown in what's going on. And for example, if I'm running like a very expensive game in just one tab that takes a lot of CPU resources, that might mean that all of the other JavaScripts and all my other tabs don't get enough time to run their code because I have to spend, or the browser has to spend most of its time inside of this very computationally expensive game, right? Does this make sense?
Yeah.
Okay. All right. But I'm sure you've noticed this before. Like, you can run your browser with 20 or 50 tabs open, and maybe it slows down a little bit, but it's not like it's coming grinding to a halt. Like maybe you might have grown an impression from what I just said. And this is like a very intentional fact, right? So the people that build these browsers have taken a lot of steps to kind of make sure that you don't have very, very severe performance penalties if you have tens, dozens, or even like 100 of tabs open. So there has to be something very, very deep going on in terms of how the browser is managing the resources for each different tab, and not just like letting everything fly and bring the whole browser crashing to a halt, right? So this is what we want to look into a little bit more. So we're going to talk about, like, very briefly, what are some of the optimizations that browsers use in order to prevent this kind of catastrophic performance issues. Well, one thing that I mentioned before at the beginning is, sometimes it'll compile JavaScript down to machine code, which can run a lot more quickly and a lot more efficiently than this thing called bytecode, which interprets what the machine should do at a layer above running just direct machine code. Again, if this doesn't make sense, don't worry about it. All it means is, like, it just transforms the code into something that's a little bit faster to write. Another thing that a browser can try to do is to parallelize execution where it makes sense. So, if I have two tabs open, sometimes I can run the code in them in parallel, and then if I run the code in them in parallel, obviously it's gonna be faster than just running the code in one tab all at once, and the code in another tab all at once, right? And it's clear that this kind of has to be happening at some level, because if you have a process that continues forever in one tab, there wouldn't be any other way for anything else in another tab to ever run if you didn't have some parallelization, right? Another thing that happens is many of these JavaScript engines are very clever and very, very optimized for how they represent the data structures that you use in the JavaScript code that you write. And so many of these things are very space and memory efficient. And if you're interested in this, you can look up a lot on how JavaScript objects are laid out inside of the JavaScript engine. But again, it doesn't matter too much for us. All we're saying is, like, here's some optimizations that are happening. And the most interesting one that I want to point out for what we're talking about today is prioritization, right? So, like, maybe something that's more obvious than all of these three before is that if I have an open tab and, like, that is where a user is interacting with currently. Obviously, I'm going to prefer executing the JavaScript that's relevant to that tab over anything else that the user may have open in their browser, right? Because again, if someone is interacting with something immediately, you don't want to spend a lot of time doing work that they don't care about at the moment. You would much rather prefer to focus on what they're staring at immediately. Okay. And so another thing that we should also point out, kind of related to what we were saying about the rendering engines for browsers, is that just like how you might write some CSS that has a lot of different overlapping styles that causes the browser to do a lot more work, you can also just as easily write JavaScript that forces the browser engine to do a lot more work, right? And so I think on some level, this is kind of an expected thing, right? So just like how you in your programming classes talk about things of various efficiency. Obviously, you can write some code that's very inefficient, or you can write some code that's very efficient for the use case that you have. And it's kind of clear that, okay, well, if I write some JavaScript this way, where like I'm doing an extra loop, then I have to. Of course, it's going to take longer than some other thing that I write that gets rid of the extra loop where I don't need it. And this part kind of makes sense, right? And maybe it's a little bit easier to reason about than the CSS example. But then you start looking at some stuff that makes a little bit less sense, right? So one tricky thing is like, how does your code get optimized by the JavaScript engine? Or if you've ever like programmed in C++ and you've kind of measured how your binaries run after you compile them, you might notice like, well, okay, like I wrote this thing, and then my binary is faster because of it. But I'm not really sure why like this way that I wrote something is faster than this other way that I wrote something. Because if you do some kind of static analysis and you look at it, you're like, well, the running time should be basically the same. I'm not sure why this one is a lot faster than the other one. And what's happening there is the compiler, or in our case, the JavaScript engine is trying to be really, really smart and saying, okay, well, I can prove some facts about how your program works, and I can kind of get rid of unnecessary work where I know you don't need it. And so in that way, it can be a lot more clever than we as programmers are, right? But for us to kind of exploit what these engines or compilers might be good at optimizing, it's not a very trivial thing. It takes a lot of measurement and a lot of digging deep into what the browser engine or the compiler is doing. And so this is what I mean by leaky abstraction. It's not like you just give this thing some code that you want it to execute, and it just does that like without any consequences to you. There are very direct consequences, because if you sort of optimize if you write your code in a certain way that makes it easy for the engine to optimize it, you're going to get a lot of memory and speed benefits compared to if you write some other way. And it's not as simple as just like, okay, get rid of this extra loop here. You have to do a lot of digging to figure out what the kind of code that you need to write is. And again, if you're interested in this kind of thing, I can give you some details, some concrete details of what those kinds of things look like in JavaScript, but that's not really what we're here for right now. The last thing that I want to point out, and this is like, we're going to do a demo about this, and this is what really may not be obvious at all, is that your JavaScript code in your tab might not be executed when you want it to, like without any notice from the browser at all, right? So this is a kind of consequence of what we said here last time, that if I have an open tab, I want to prioritize running JavaScript in that tab. And so the browser might say, okay, well, here's some other tab that's not open right now. I'm not going to run JavaScript in it, while the tab is open. And you can say, okay, well, for the user, that's all fine and good, but for the person that is running the code for that tab that's not currently active, maybe you need that code to be executing, in real time. And if it's not, that's not like a very obvious thing to test unless you know beforehand, oh, I know that browsers might not run my code all the time. And how do I sort of get around this fact? Okay, so maybe you don't believe me. So we're going to do a little demo here. All right. So I have two things going on here. Let me open up another tab. Open the New York Times. All right. So I'm going to open up this timer.html, which is going to have like a, well, let me just do this right now. All right. So it's just going to count seconds that have passed since we opened the web page, right? And over here, I'm also going to start a Python process that is also going to count time for us, okay? So we're going to try to synchronize them. Maybe it'll be like a second off, but all right, so let's press enter here and reload here. Okay, so they're like mostly synchronized, right? Maybe like a second difference, but it's okay. So now let's do some work on this page. Like, all right, let's check out this author about Lawrence Filighetti. Cool. Let's check out one of the poems that he wrote. Okay, page not found. Well, I guess the New York Times should fix that one. But all right, so we've done some other work in this active tab, and now let's go back over to this thing. Well, look at that. For some reason, time has stopped in our timer.html tab, right? And now we're like almost 20 seconds behind the actual real time that has passed in the user's life, right? And to me, this is not an obvious thing at all, right? I don't think it's very obvious, especially if you don't know about this fact beforehand, that that time should be going slower in tabs that are not being used versus tabs that are being used. And this is immediately something that you have to think about, right? So here, I'll give you guys another example. Like someone posted, someone in like the math Discord or something posted this game that has you basically writing LaTeX code. It's like one of these like very nerdy games, but it's a good time. So you start this thing, you start like a timed game, and it's like, okay, I have 3 minutes to do my thing. But this counter is happening in the tab. It's happening with the JavaScript running in the current tab. So I can go over here and I can look up like LaTeX how to do integral or something, right? And I check out overleaf and it tells me like, okay, like here's how I write an integral in LaTeX. And I can be like, okay, like let me cheat with that thing. And actually it has been more time than this 15 seconds that was reported by this counter here. But this tab doesn't know that. This tab doesn't know that on its own. And so you can kind of start thinking about like, what are the consequences of this kind of thing? Like obviously there's some kind of potential for security vulnerability, for example. So like, if you have one of these games and you just let people take as much time as they want, anytime they want it, just by opening a new tab, I mean, I don't know. could be not good for the people that don't know about this hack, right? Yeah, so I mean, you could try for a test. I don't know if I would risk that one, but would be an interesting experiment. You know, next time you have a bright space quiz, try it out and let me know how it goes. All right.
Wait, so I have a question.
Yeah.
So this thing this phenomenon, does this also explain, let's say if you're in a tab right now and you open 3 other tabs, let's say 3 other Gmail accounts, right? I just log in to 3 other different Gmail accounts and open Gmail in 3 other separate tabs, right? But
yeah,
none of them really load unless I actually go to one of them. Let's say I change it to another tab and it loads and I have my Gmail, but the other 2 that I open new tabs for, they're still just in a loading state. They never render completely. Does this phenomenon explain that same thing?
Yeah. I mean, so there's like a little bit more going on than just the JavaScript execution, right? Like there's also the actual like fetching of data from the network. When you say, okay, I want to go to gmail.com, it actually has to like fetch all that data, and then it has to render stuff too, and then it executes JavaScript. But yeah, you're definitely right. Like all this stuff gets kind of pushed to the background until you say, okay, I actually want to go and do this thing now, and the browser says, all right, like now I'll do some work that you're making me do, right? Because it's being kind of lazy. That's really what's going on. It doesn't want to do anything more than it has to. Okay, so we're almost out of time. So I'll skip over this demo, but I will, I'll put the slides in that central repository that I mentioned earlier. And so you can check this out. This is also like another interesting case where JavaScript is doing something, the way that JavaScript runs, the way that the browser runs your JavaScript and renders, your UI is behaving a little bit differently than you might expect. And this is also what to me is not an obvious problem. And in fact, GitHub just this past month, even I think, had this problem when they were sort of looking through their front end code and saying, okay, we're having like a very poor response time. Why is it happening? They said, oh my gosh, here's this like non-obvious problem that we found. Okay, so if anyone wants to answer this one, maybe this will be like our closing remark. So maybe it's kind of clear, but if we have these kind of non-obvious facts about the way that our browser executes JavaScript or does other things. So let's say we have these non-obvious phenomena, and also they're non-obvious and they differ between different browsers. What are like some of the consequences of this for us?
I mean, it's probably really obvious to say that it makes it much harder to like develop like a complex web app or whatever, right? Because you have to accommodate for so many different factors now. But I'm sure there's other things, right?
Yeah, but like that's exactly the point. And that's kind of like what what this whole kind of session has been trying to be about. So as you were saying, the point here is that there's a lot of things that are going on. A lot of them are kind of below the surface that we might work on a day-to-day basis. And a lot of them are really, really not sort of clear to see or even like easy to access unless you have some experience and they're like, wait, that doesn't make sense to me. And you start digging deeper and you figure out, aha, this is some phenomenon that I didn't expect, but now I have to know about because I'm relying on it for this application that I'm building. And and this starts to increase the amount of things that you have to care about and the amount of things that you have to consider in the design of your application. And of course, if you now also add this fact that browsers might also behave differently, well, now it's like, well, not only do you have to know how the phenomena of a single browser affects my application, I have to know how the phenomena of all browsers affect my application. So it gets very, very difficult very quickly. Okay, so just to wrap up, we're already 2 minutes over, but the real point that I want to kind of bring home today is that everything here is dependent on how the browser works, and there's no way that we can design a scalable web application and have a good understanding of how it interacts with the user or with anything else going on in the environment that the web application is being used without having a deep understanding of what the browser is doing. Okay. Yeah, and so this is exactly what that's saying. There are a lot of sort of different things that you can do when you write a web application, and you have to think about not only like how does this change how my web application looks like, or how does the user interact with it. You have to deeply think about what are the consequences of what I'm doing for the thing that's actually going to execute the code that I write, and that thing is the browser for the most part. Okay, so we kind of skipped over the summary there, but I think you all kind of get the message, I think. If not, please stop me and say, let's go back. That doesn't make any sense. Next time, so 2 weeks from now, I think, we're going to talk about networks, web protocols, servers, and databases to kind of lay out the rest of our understanding of what the sphere on the web looks like. And then after that, we'll dive into more of these interesting phenomena that are happening and think about what are the kinds of things that we can do to offset their effects and the benefits and trade-offs that different options that we do have. Okay, so we'll close off. If anyone has any questions or any comments, please drop it in the chat or just say it out loud.
For the Notion, it says you do not have access to Bandy Hacks. Please contact an admin. Does someone else have the same thing as well?
Yeah, we'll send another link to the repository. I think this link is kind of broken, but we'll send another one later.
Thanks.
Also, guys, we have a feedback form, and if you have time, we'd really appreciate filling out the feedback for this session. We really want to make it better, even more better than it is right now. And if you have time, please fill it out.
Yeah, so here's a link for the feedback form. Please do fill it out. It gives a lot of insight for what you want the next time we have this session. Because again, there's not much point to doing this kind of thing if the viewers aren't getting something out of it. Yeah. Okay, so with that, thank you all. Sorry for going 6 minutes over. I hope you learned something. I hope it was a good time. Hope to see you soon. Thank you.